All right, welcome everyone to this explainer. Today we are literally cracking open the intelligent anatomy of modern networks. We're going to take a really deep dive into a technology that's fundamentally rewriting how global businesses communicate, operate, and honestly, just survive in a cloud-first world. We are, of course, talking about SD-WAN. If you've been wondering how companies effortlessly manage data across thousands of locations without their networks just totally collapsing under the weight of modern cloud apps, well, you are in exactly the right place.
Okay, let's dive into this. Here is our roadmap for today. We're hitting 1. The catalyst, 2. The brain, 3. The reflexes, 4. The showdown, and wrapping up with 5. Real-world impact.
To understand the cure, we first have to understand the disease. So, Section 1, the catalyst, the traditional WAN problem.
So here's a big question for you. Why on earth are enterprises abandoning MPLS? I mean, for decades, MPLS, multi-protocol label switching, was the undisputed king of enterprise networking. But today, you've got global giants from Amazon down to everyday businesses dropping these expensive, traditional circuits for something much, much smarter. You might be thinking, why fix something if it isn't completely broken? Well, to answer that, we need to take a quick step back.
Just to make sure we're all on the exact same page, let's look at the WAN itself. A wide area network connects our geographically dispersed locations. Say your company has a head office in Mumbai, maybe a branch in Delhi, a factory in Pune, and then all your cloud apps are sitting in AWS and Azure. All of these spread out resources need to talk to each other seamlessly, right? Historically, tying this giant puzzle together meant running dedicated private links between every single node.
And that brings us to the real issue with MPLS. While those traditional dedicated links are super reliable, they have some massive limitations today. First off, they cost an absolute fortune compared to standard broadband. Second, deployment is just painfully slow. Adding a new office can take weeks or even months just to provision one new circuit. But the real killer? Cloud latency. In the old days, all your apps lived in a physical data center at HQ. Today, they live in the cloud. Yet traditional static routing stubbornly forces all that remote branch traffic all the way back to headquarters before it can actually go out to the cloud. We call this hairpinning, and it causes terrible latency. On top of all that, admins are stuck with poor visibility and rigid, static routes that just can't adapt.
Let's move to how this builds into our first major technical focal point, Section 2, the brain, architecture, and control plane.
To truly master SD-WAN, we have to look under the hood at its architecture. It basically breaks down into 4 main components. First, we have the SD-WAN edge. These are the actual physical or virtual devices sitting out at your branch offices. Next, and absolutely crucial, is the controller. I want you to picture this controller as the intelligent, thinking brain of the network. It's the central authority applying policies to the whole system. Third is the orchestrator, which is essentially your graphical user interface, making management beautifully simple. And finally, the gateways, which act as your secure, direct doors into cloud services.
So, the crucial point here, the real paradigm shift, is radically separating the network's control plane from the data plane. Think about it. In a traditional setup, every single router had its own tiny brain and its own map, and a network admin had to manually configure every single one of them. What SD-WAN does is rip that control plane right out of the individual devices and centralizes it in the controller. The data plane, the actual heavy lifting of moving the packets, that stays out at the edge. But the decision-making, that happens centrally. You're no longer configuring routers one by one, you're managing the entire WAN from one centralized brain, which instantly pushes those instructions out to all the edge devices at once. It's an unbelievable leap in efficiency.
Okay, so we have a central brain, but how does it react to the real world? That brings us to Section 3, the reflexes, traffic steering mechanics.
This is where SD-WAN gets incredibly agile. Imagine your office has broadband, fiber, and maybe a 5G connection all running at exactly the same time. Instead of just picking one path and blindly hoping for the best, the SD-WAN controller is constantly feeling the network. Step 1, it continuously monitors the exact latency, packet loss, and jitter of every single link in real time. Step 2, it identifies exactly what the application needs. Step 3, it shifts the traffic dynamically. If a broadband link suddenly degrades or drops, boom, the traffic instantly shifts over to the 5G or fiber link. It happens so fast and so automatically that a user on a live video call won't even notice a blip.
Now, what's really interesting about this is how SD-WAN handles application-aware routing. Because let's be real, not all data is created equal. A live Microsoft Teams or Zoom call requires absolute minimal latency, so SD-WAN immediately assigns it to the fastest, cleanest path available. But what about a massive overnight data backup?
That doesn't need to be fast, it just needs to get there. So, SD-WAN intelligently routes that backup traffic over the cheapest, highest bandwidth connection, keeping your premium paths wide open for business-critical apps. It's automatically treating different types of data with distinct priorities.
So, we've seen the brain and we've seen the reflexes. Now it's time to put this all head-to-head. Section 4, the showdown. MPLS versus SD-WAN.
And this brilliantly illustrates the difference. I want you to think of traditional MPLS as a dedicated railway line. A train on a track is incredibly reliable, right? But it's fixed, it's inflexible, and it's extremely expensive to build. If there's a problem on the track ahead, the train just has to stop. SD-WAN, on the other hand, is like an intelligent GPS navigation system in your car. It sees the whole grid. It dynamically routes your traffic based on real-time conditions. So, if there's a traffic jam on the main highway, it instantly reroutes you down a local expressway to make sure you arrive right on time.
When you actually stack them up in a grid like this, the technical superiority of SD-WAN for modern enterprises is just undeniable. Look at the cost. MPLS is sky high, while SD-WAN is significantly lower because it's actively leveraging standard broadband and internet. Deployment speed goes from agonizingly slow to fast and agile. But the real kicker here is cloud readiness and application awareness. MPLS was built for an era way before the cloud existed. It has zero native application awareness. SD-WAN is built natively for the cloud. It just entirely outclasses legacy networks in a modern setup.
All right, theory and architecture are great, but let's ground all of this into a concrete business reality. Section 5, Real-World Impact.
Picture this. You've got a massive retail chain with 500 stores scattered across the country. Every single store is running point-of-sale systems, security cameras, inventory, cloud ERPs, the whole shebang. If they were using legacy MPLS, they would be paying an absolute fortune for 500 private circuits. But with SD-WAN, they can blend inexpensive broadband and 5G together seamlessly. Using that central brain and those dynamic reflexes we just broke down, the system ensures that business-critical point-of-sale transactions always get priority routing. Actually, let's say a local ISP goes down because a construction crew cuts a fiber cable down the street. The active failover just automatically switches the store to 5G. The cash registers keep ringing, customers have no idea anything happened, and the company drastically lowers its overall WAN costs. It's a win-win.
Now, understanding this SD-WAN architecture is absolutely crucial right now because it's the foundational stepping stone to the future of all enterprise networking, SASE. That's SASE, or Secure Access Service Edge. It basically takes the incredible networking intelligence of SD-WAN that we just learned about and combines it with deeply integrated cloud-delivered security services like Zero Trust and secure web gateways. Simply put, you cannot build a modern SASE environment without first mastering that SD-WAN control plane and data plane separation. Which leaves us with this final, pretty major question. Take a hard look at your own enterprise infrastructure. With applications living everywhere and users demanding instant, flawless access, static routes and rigid pipes are simply not going to survive. Is your current network architecture actually ready for the cloud-native future? Are you still driving a train on a fixed track, or are you ready to upgrade to a fully intelligent, dynamic navigation system? Thank you so much for joining me on this explainer today. Keep learning, keep questioning, and I'll catch you next time as we continue to unpack the technologies that are shaping our world.